for this Algebra 3 review, 3B, Part 2. The year is 2020. The school year is 2020-2021. This is 4th hour. The date is 10/12/20. It is officially, well, it was 10:41 a.m. It's now 10:43 and 9 seconds a.m. I have to drive the bus tonight. I'm not amused by that. There are currently in this room 9 sophomores, 6 juniors, 2 seniors, 1 teacher, and as we would all say, that is good. And they are learning. We are ready for question number 15 as we start part 2. Previously on Algebra 3, we did several questions all over the place. All right, question 15. I3 or I cubed plus 3 minus negative 3i all over 2 minus I. Now I can tell you that the first thing you're going to do is you're going to simplify the numerator. And whenever we go to divide by the denominator, right, we are going to multiply by the conjugate. That is the step that is most commonly forgot on these questions. I cubed. So for this, I'm going to go ahead and kind of write this up like this. We can go ahead and make that a plus 3i. Okay, that gets rid of a couple of things for us. All right, 2 of these i's are going to make it negative 1. So we got negative 1i plus 3 plus 3i. We can combine like terms. Negative 1i plus 3i is 2i plus 3. Really, it's better written as 3 plus 2i. Okay, does that make sense? Okay, and we just need to get used to that order because we're going to work with problems later on where that order is really important. You're already working kind of with that order whenever we look at things along the lines of like polar coordinates and rectangular coordinates, that type of thing. All right, so what we have coming up to, let's see, let's call this part 1. Part 2, okay, we're going to bring this up. We got 3 plus 2i over 2 minus I. And a lot of people stop there. They say, that's the answer. Can't do anything more than that, right? And they put that on there. And it's going to be wrong because there's too many steps left to do, okay? The next thing left to do, 2 plus I times 2 plus I. We FOIL across here. 3 times 2 is 6. 3 times I is 3i. 2i times 2, 4i, which is not a nice thing to call somebody. 2i times I is 2i squared, or, well, let's go ahead and write it as 2i squared, just so that we see that step being done. All right, so we have 6 plus 7i. And then we have plus 2 times negative 1. Again, you guys know these steps, and I could say them, but so that we see them for the benefit of everybody, we have 6 plus 7i minus 2. Continue to combine like terms. So I have 4 plus 7i. Questions? Okay. All right, now we have our numerator. Okay, we'll call this, I guess we can call it part 3. We're going to hold on to this because that's my numerator. We need the denominator, sorry. Okay, so let's see. Notice that our numerator in these questions is always going to be a sum difference. So do I need to completely FOIL? No, because my middle 2 terms will always cancel out in a sum difference. All right, I really just need the first and last. Okay, 2 times 2 is 4, and then negative I times I is negative I squared. Okay, now this is where it gets a touch complicated. Okay, it's 4 minus negative 1. Okay, which is 4 plus 1, which is equal to 5, right? So final part here is I have 4 plus 7i divided by 5. You can write it like this, or you can write it as 4/5 plus 7/5 I. Either one is correct. Okay, either one will be right on the test. Let me move See some of you trying to see around that. Okay. Questions? Okay. Step 1, simplify the numerator. Step 2, multiply by the conjugate. Step 3, simplify numerator, simplify denominator, combine. Okay? No questions on 15? Excellent. All right, question number 12. There's strange screaming outside. It's probably the beginning of the zombie apocalypse. We'll just lock the door. So we hear them, just zombie bodies beating themselves against our door. Just concentrate on our review. Okay, we have things to do. They'll eventually go away. Okay, all right, so we have a picture for this one. There's probably an easier way to have done that, but yeah, let's maybe just make one big triangle and then make a line later. Okay, how about that? That's a little better. All right, we got a right angle here. Right angle here. This is 5. We got 15. B and A. We got C and 12. The way I choose to look at this is as two separate, similar right triangles. Okay, where this is C plus 12, this is B plus A, and this is 15. Right, and I've got this smaller one here, which is 12, 5, and A. Okay, does that make sense to look at it that way for you? Now, they're similar right triangles because of the angle-angle similarity postulate, right? They both have this right angle, and this angle right here is shared, right? Meaning reflexive axiom of that angle. All right, so that means that their third angle, by definition, is the same. So angle-angle, right? Similarity postulate. So triangles that are similar are proportional. I can go ahead and solve A really easily, though, right? Okay, because we're just going to use the Pythagorean theorem, okay? All right, actually, I'm going to call that step 2, because I would really call this, setting it up like this, step 1, okay? All right, so we've got 5 squared plus 12 squared equals A squared. We got 25 and 144. Okay, they're typically going to give you things that work out pretty nice. Okay, so that's 169, which I think, as we square root it, is 13 equals A. Okay, so as we kind of come back up here, now we can substitute this with 13 here and here. Okay? All right, so the next step is actually setting up a proportion that we can work with. Right? We can compare 15. Let's say we wanted to do 15 over 5. Okay? The question for you guys is, if I'm doing 15 over 5, all right, what do I want to set up the other side as? Okay, C plus 12 over 12. Okay, now it's a matter of cross multiplying. But as I do, I need to distribute the 5, right? So that's 5C. And the big mistake that people make here is they'll distribute the 5 to the C, but they won't distribute the 5 to the 12. And they'll wind up with 5C plus 12 instead of 5C plus 60. All right, and then we need 15 times 12, which 180. Okay, subtract 60 from 180, which is be a what, 120. 5C equals 120. Divide by 5. So you say C equals what? 24. All right, so we've got C is 24. We've got A is 13. And we're going to basically replicate step 3 for solving for B. Or, well, there's a couple different things you can do here. We know that C is 24, right? Okay. So we can actually take this triangle here. I don't know if I recommend this or not because I don't want to confuse. All right, we know that this entire length down here is now 36, correct? All right, we know this is 15. Could we find what the hypotenuse is? All right, and if we found out what the hypotenuse was, we would just subtract 13 from it and we'd be left with b, correct? Okay? You don't have to do it that way. There's multiple ways once we get to this step to do it. I'm going to continue to do the proportion method. Does that make sense? Okay? Just so we're not throwing too much out there. So, all right, so step 4, I'm going to keep 15 over 5. And what was that? It was would be b plus 13 over 13. Okay? So now we have 5b plus, what, 65 equals 15 times 13, 195. Okay, subtract 65 from 195, you should get what, 130? Okay.
26.
Okay, so I got 5b equals 130. Divide by 5. You said b equals 26. Okay, there's your A, B, and C. Any questions about that? I'll actually give you 2 moments. Okay? But they won't be magic moments. Okay. All right, question number 8. Solve by completing the square. You don't necessarily need to solve by completing the square. I'm trying to think, because it's been a while since I solved by completing the square. Well, let's see if we can do that. Okay, we got... If you want to use the quadratic formula to solve, you can. But because it says to do it a certain way, I'm going to try to do that for you. Okay, because we really need to practice in solving by completing the square, right? Because it's not some, like we have a couple of examples that we've done and put into the classroom, but it's been a while since we've actually done one, right? All right, so we're going to rearrange some things. We can call it kind of step 1, where we have 2x squared. We're going to subtract 4x back across, and we're going to add 7 over to this side. That makes sense. Okay? The next thing I believe that we need to do is I think we have to divide by 2. We have to divide everything by 2. Okay, so we got x squared minus 2x equals, we can just call it 3.5 for now. This next part, though, is where we take negative 2 divided by 2 and square it. That leaves me with x squared minus 2x. What's negative 2 divided by 2? Okay, and what's negative 1 squared? Plus 1, right? So we're going to take that plus 1 here, and we're also going to get where we add 1 over there. So that equals 1, so we plus 1, so we see that working. Okay? All right. So let's see, this is 9/2, I guess what you would call. You just got to stick to the quadratic. No. All right, so the question is, where did the 9/2 come from? We know how we got 7 over here, right? Yes? Yeah, it's 4.5. Okay, I'm trying to make sure that I haven't done it wrong. In fact, let me kind of scoot over here to the answer key and make sure I haven't told you something wrong. Oh, goodness. Yeah, now I have to pause it and do this whole thing. Okay. So from here, we're going to factor this right here. Okay? So we're looking for things that if I break it down into this, I'm getting this front row, this left-hand side right there. Does that make sense? So minus, okay, 1 and 1. Does that make sense? Well, I'm multiplying two numbers to get 1. What's the only way to multiply two numbers and get 1? For it to be 1 and 1, but it's positive and this is negative, so it has to be negative, negative. So what I'm getting in here is x minus 1 squared. Right. Okay. Can I erase this bottom? Well, here, we'll just skip down. Okay, so from here, we are square rooting x minus 1 squared, and we are square rooting 9/2. Okay, to get x minus 1 equals plus or minus square root of 9/2. Okay, and then add 1. So x equals 1 plus or minus 9/2. Let's
2.1.
Which what they do with 9/2 is they simplify that. So what do they wind up with there? They wind up with 3. Hold on. What do they do there? I made that a lot more complicated. You all right? Oh, you just had stuff. I would take this as an answer. Or sorry. Did you get the same thing when you did the quadratic? Yeah, I'll show it to you in the quadratic. All right, so this is number 8 as the quadratic. All right, it starts off as, so we have 2x squared minus 4x minus 7 equals 0. Okay, that's what it gets changed to, correct? Okay, I know that's not what it looks like to begin with. It looks like negative 7 plus 2x squared equals 4x, but we move everything to the left-hand side, correct? All right, so we have an A, a B, and a C, and our quadratic formula is negative B plus or minus the square root of 4AC, no, B squared minus 4AC all over 2A, okay? If any part of this is wrong, your answer will be wrong, okay? You have to know what the quadratic formula is if you're going to use it, okay? Notice that my B is already negative, so whenever I go to plug it in, it is positive. So I have 4 plus or minus the square root of negative 4 squared, okay? Minus 4 times 2 times negative 7 all over 2 times 2. Okay, so I have 4 plus or minus all over 4. 16 minus 76. You probably are right. Okay. So would be what, 16 plus? 16 plus 56. Okay, so I got 4 plus or minus. What is 16 plus 56? 72. Square root of 72 all over 4. Okay, and we want to take 72 and simplify it. Okay, we can divide it by 2 and we get what, 38? Divide by 2 and we get 19. Okay, 19 is prime, isn't it? Oh, yeah, that's right. 36. Sorry. Thank you for catching that. 36. Then that's going to be what, 12 and 3? Okay. So we've got a pair of 2s, another pair of 2s, and a remaining 3. So I wind up with 4 plus or minus 4 radical 3 over 4, which will simplify, right? Because their answer is different, though. Hold on, 72 divided by 2 is 36. Give me a second to think. That's a 2. 2 is 4. 4 radical 3. They're getting 3 radical 2. I've done something wrong. Or you guys have given me a wrong number somewhere. 56 and 6 or 56 and 16. Okay, 72. We got the 4 and the 4. We should be fine there. Let me start over with this. Um, oh, right. Yeah, I know. I'd messed up earlier. Okay, I messed up. Okay, so we're winding up with 3 times 2, which is 6 radical 2. Okay. So we wind up with, well, 1 plus or minus, what would that be, 3? 3 radical 2 over 2. Or you could have 2 plus or minus 3 radical 2 all over 2. Six fourths simplifies to be 3 halves. 6 fourths simplifies to be 3 halves. When you divide both 6 and 4 by 2, 6 divided by 2 is 3. 4 divided by 2 is 2. Questions? So completing the square, quadratic formula, spent a whole lot of time for a question, you guys. I don't know that I might have made a mistake on this part over here. Well, up to here, I know that I did this part of it right. I think it's simplifying the square root of 9 halves. I think I know how to fix that, though. Okay. Because, let's see, this is technically the square root of 9 over the square root of 2, right? What's the square root of 9? 3, okay? So now I can't leave that. So I've got x minus 1 equals plus or minus 3 over square root of 2. Well, I don't know if you remember this, but you can't leave a radical 2 in the denominator. You have to multiply by radical 2 over radical 2, right? Okay, so you're winding up with x minus 1 equals plus or minus 3 radical 2 over 2. Add 1, x equals 1 plus or minus 3 radical 2 over 2, which is the same as what we got over on the other side. Sorry, I should have finished it. Okay? All right. Let's see, 7. We're moving incredibly slowly through this. Seven. Use the quadratic formula to solve 3x squared. Okay, great. Hopefully this goes quicker. So they have 3x squared equals 2x minus 4. We're going to bring everything on the right over to the left. So I have 3x squared minus 2x plus 4. Does that make sense? Okay. All right. Rather than writing the quadratic formula again, right, I'm just going to start putting things in. So we should get 2 plus or minus square root of negative 2 squared minus 4 times 3 times 4. See you later. All right, I'm just going to keep going here while you guys are. See you later. 6. Let's see. We've got 48. 4 minus 48. So it'd be negative 44. Negative 44. Okay. Let's see. So whenever I have a negative in the square root, what comes out? I comes out. 2 plus or minus I radical 44 over 6. 44 is 2 and 22. 2 and 11, so 2 comes out. So I wind up with 2 plus or minus 2I radical 11 over 6. 2/6 reduces to 1/3. So 1 plus or minus I radical 11 all over 3. You can split it if you need to, but that's the answer. Is that a little bit simpler than the other? Okay. All right, what was that, 7? All right, we ready for 1? 1. The ratio of priests to acolytes, I'm just going to write down what I'm reading here, was 2 to 3. Okay, priest to acolytes was 2 to 3. I'm going to go ahead and rewrite this as 2a equals 3p. Does that make sense? Do we know how I got that? Okay. All right, then they give you another equation. They said if their combined total was 85, that means P plus A equals 85. Okay? Okay? How many were not acolytes? That is meant to confuse you. All right? What is not acolytes? Priests. Solve for P. Okay? Don't see acolytes and think you solve for acolytes. You're solving for P, so we need a P equals. All right, so what I'm going to do with this equation right here, right, is I'm going to subtract P. I'm going to subtract P, so I'm going to get A equals 85 minus P. okay, because I want to get a's out of the equation. So okay, now I'm solving in terms of p. Does that make sense?
Yes.
All right, so I've substituted this in for that a right there. Okay, now distribute. So 85 times 2 would be what, 170? Minus 2p, don't forget to distribute to everything, equals 3p. Isolate p, so add 2p to both sides. Okay, so I got 170 equals 5p. Divide by 5. P equals 34. That's what they're looking for. Priests equals 34. P equals 34. Okay, do you understand the steps? Okay, practice the steps. Okay, identify, okay, this is what I'm doing. I'm going to set up a proportion. Okay, I'm going to solve that proportion. I'm going to write the next equation. I'm going to solve that equation for the opposite variable that I'm trying to solve for. So I know that's kind of weird there, but notice how I solved for a instead of p. Okay, because that allowed me to get things in terms of p. But let's say that you made a mistake and that you actually solved for a down here, right? You can still, once you have found a, substitute it back in and solve for p. Your best bet is probably to go ahead and solve both variables and list p and a, and I guarantee you I can't count it wrong so long as your number is right. Okay? So if you're uncertain, just solve for both variables. Okay? All right. Number 2. Okay, we're getting into fewer and fewer people miss these, so that's good. Find the sum of the measures of the interior angles and the sum of the measures of the exterior angles of a regular nonagon. All right. Nonagon. We need sum of the interior, sum of the exterior. Okay? Sum of interior of angles of a regular polygon. There is a formula for this. They're on their way. Should I call down there and tell them that they're on their way? Let me. Okay. So sum of the interior angles of a regular polygon is done off by the formula n minus 2 times 180. I think I described this on the board by showing that shape and splitting it into triangles where it has a common vertex back to a single vertex on the shape. Okay, so if we have 9, we have 9 minus 2 times 180. Okay, so I got 7 times 180. Okay, what's 7 times 180? 1,020. 1,260. Okay. 1,260 degrees. Now, what will cost you on this question is mixing up interior and exterior angles. This is interior. Yep. Exterior, or some exterior, or interior. Interior measure angle, 1,260. Exterior is always what? Okay.
Do you have to clarify that on the test?
Yes, I want to know which one's interior, which one's exterior, and that's not asking too much, I don't think. Okay? If you flip-flop them, provided they're both the right numbers, I'll probably count off half. Okay? Number 11. Is the following argument valid or invalid? So it says all English teachers like, I'm going to say Bill, short for Shakespeare. Real quick, What is the major premise? All English teachers. This is the major, or English teachers specifically. What's the minor premise? Like Bill. Okay? And it says Mrs. B is an English teacher. Okay? Is this valid or invalid? Or, well, I guess therefore, Miss B likes Bill. Right? Valid or invalid? Valid. Why? Right, because it's based upon the major premise. Valid or invalid is fine. Okay. All right, that was 11, 18. Okay, state the congruency postulate can be used to prove. Okay, so that's all it needs. It's just the congruency statement. So they start off with something that looks somewhat like this, kind of like a parallelogram. Okay. A, B, C, and D. Okay. So we're looking for a triangle congruency statement to prove that triangle ACB is congruent to triangle CAD. Okay? Now, they have an angle that's congruent to an angle. They have a side that's congruent to a side. That's not enough. We don't have like side angle congruency postulate or angle side congruency postulate. We don't have enough information. Okay, at least not through tick marks yet. Is there anything else that's congruent? You said AD. Well, we already know that though. I'm talking about something that isn't already listed with tick marks. Can we prove that, angle ACD is congruent to angle CBA at this point? There's something that's really obvious. AC and AC. Right? This line is congruent to this line and it's shared by both triangles. So we would say, if we were writing a proof, we'd say AC is congruent to AC through the reflexive axiom, which is short for reflexive property of congruence. Okay, but we say axiom. Now if I look at what I have side, angle, side. I have side, angle, side. Is that enough to prove that those two triangles are congruent? So my statement is side, angle, side, congruency postulate. Okay? This is what they're looking for on that. Is it said it just wants the congruency postulate. Okay? But I'm trying to show you why. Okay? 17. All right. Outline the proof that shows. Our time is up. Okay. Let's see. But we didn't hit 3 questions. Are you guys going to survive? Huh? I'm gonna make a video out of this. We're gonna hit stop right here. It does? Okay. Okay.